All right, so here's the chapter on the solar system, chapter 15. So the solar system is our local neighborhood. Everything in the solar system is affected by, of course, the sun, the gravitation of the sun. And around the sun, of course, we have planets. The planets were redefined a few years ago, and now we also have what are called dwarf planets, and that includes, of course, Pluto, which is no longer considered a major planet. The thing is, Pluto hasn't changed. Pluto's still there. It's just the definition of what a planet is has changed, and so we had to redefine the status of Pluto. And of course, there are other things like comets and asteroids. Beyond the orbit of Neptune is a region called the Kuiper Belt. Actually, Pluto is now just considered a member of the Kuiper Belt. We'll talk more about that in detail. All right. Let's see. So this is actually wrong as far as the date here. It was actually in 2003. Just to give you a little background, 2003, 2004, when an astronomer discovered an object beyond the orbit of Pluto, and this object, which later became known as Eris, was he did a quick calculation, and it turned out that this object was more massive than Pluto, and even in those that first discovery, it seemed that object even had its own moon. And so this guy went home, told his wife, "Hey, I think I found the 10th planet." And it turned out that he did find an object, and this object is larger than Pluto. But the thing about it was around 2007. This should actually say 2007. The International Astronomical Union got together and had to make a decision, and there were many possibilities. There was one thing that was floating around for a while was anything that is round and orbits the sun should be considered a planet, and at that point there would have been well over 50 planets around the sun. And then some other people proposed something, and now with a little bit of perspective, it's been many years now, since 2007. The new definition of what a planet is makes a lot more sense. It can't just be round and orbit the sun. It also has to clear the path around. As it orbits the sun, it has to clear a path. And so Pluto doesn't do that. There's lots and lots of objects that are right around the orbit of Pluto, and also Eris. Like I said before, those are called the Kuiper Belt. So now we have 8 planets. There's well over 100 moons, thousands upon thousands of asteroids, perhaps millions of comets. We'll have more to say about their origin. They come from a region, it's actually just a proposed region that surrounds the solar system in a spherical manner, called the Oort cloud. Nobody's ever actually seen anything in the Oort cloud, but I'll get more into this later. It does make sense that it's there. One of the standard units of distance when you're talking about the solar system is 1 AU, or 1 astronomical unit. And an astronomical unit, as it says here, is approximately 1.5 times 10 to the 8th kilometers, or 1.5 times 10 to the 11th meters. The reason I say that the average, what it says here, the average distance is, of course, the distance between the Earth and the Sun vary. We're closest to the Sun right around the beginning of January. Usually January 3rd or January 4th, and And that always puzzles people. That if we're closer to the sun, isn't it a little bit, shouldn't that be summer? But remember, summer, the seasons are determined by the angle that the sunlight hits the Earth, and of course the Earth is tilted 23.5 degrees, and so that's what determines the northern hemisphere at that time is of course in winter, and it does receive a little bit more sunlight just because we're about 1 million miles closer to the sun, but it's not super significant. There are what are called terrestrial planets. So the first four, of course, are the terrestrial planets. They're also known as the rocky worlds. And then there's the giant planets. Of course, they're also known as the Jovian planets. Jove, of course, is another name for Jupiter. The rocky planets, the rocky metallic worlds, are, of course, as it sounds, made of rocky material, silicates, and of course metals, particularly iron and nickel, which generally are found in the core of the planet. And then there's the giant planets, and these are gaseous, or also known as gas giants, and they're composed mostly of hydrogen and helium. There's some amounts of methane in there as well, but the primarily hydrogen and helium. And of course, as I just said, Pluto is no longer considered a planet. All right. This is just the order of the planets. Notice between Mars and Jupiter, this region right here, this is the main asteroid belt. That's where you find most of the asteroids in the solar system. Just briefly, Mercury is a very, very tiny planet. It's a dead world. Its distance from the sun is about 0.4 AU, and its orbit, as it says here, is highly elliptical. That means it gets a lot closer to it gets closer to the sun. This is of course the average distance. It gets closer to the sun and further from the sun, but it's a very elongated orbit. It takes about 90 days or so for Mercury to go around the sun, and its period is close to 60 days. So it's about 2/3 the orbital period, and that's because the Mercury is so close to the sun that it actually feels a tidal effect, the way we feel. The moon and the Earth are give the moon affects the Earth tidally. All right. The thing about Mercury is it's really hard to see. I mean, in my entire time of looking at the planets, since I was a kid, it's like a handful of times that I've actually been able to see Mercury. The problem, of course, is because it is the closest planet to the sun. It has no moon. That's beside the point. But the thing is, because it's so close to the sun, from our perspective on the Earth, let's say the sun sets, Mercury is not far behind, right? Or the sun rises, or the sun's about to rise. So Mercury is either in the western sky right as the sun sets, and so it's never very far from the from. All right, so let's see. I can't really remember where I left off. All right, so basically, it's really hard to see Mercury because it's really close to the sun, and from our perspective, it's either very close to, in the western sky, it's very close to the sun. After the sun sets, if it is even visible, you're not going to see it really high in the sky, and all right. Anyhow, it has no atmosphere. It's extremely cratered. It basically looks like the moon, and of course it's the smallest of the 8 planets. There's a nice picture of it. Of course, we've sent spacecraft to all 8 planets, and to study them. Or let's see, let's go on. Venus is basically almost a twin of the Earth. Of course, it's closer. It's only a 0.7 AU. Just like Mercury, it doesn't get very far from the sun. So in the morning, if you can see Venus in the morning, it's to the east, right before the sunrise, and then in the evening it is always to the west, just after sunrise. You never see Venus, directly to the south or something like that. We can't see it that way because of our position in the solar system. So Venus, actually, if you have even a pair of binoculars or a small telescope, you can see the phases of Venus. Venus, it's very strange. All the planets revolve around the sun, of course, in the same direction. It's a counterclockwise direction. If you were looking down on the solar system, if you went north of the plane of the solar system, right? The solar system exists in a flat plane, which we call the ecliptic. And if you were to look down from the north onto it, everything is rotating, is revolving around the sun counterclockwise. Okay, Venus it actually rotates. It's basically like it's been flipped upside down. So its rotation about its own axis is opposite the direction of the orbit. So it's actually rotating about its axis clockwise, which is very different from the other planets. Its day is actually longer than its year. The year, I forget how long Venus's year is. It's obviously less than the Earth's. I think it's more than 100 days. Anyhow, you can just look that up. Its atmosphere is extremely thick. In the 1970s, the former Soviet Union sent various probes that actually landed on Venus, the Venera probes. They did not last long. Venus is sometimes called a hellish world, and that is very, very accurate, because of its very thick carbon dioxide atmosphere. It basically traps. It's like a runaway greenhouse effect, and so the surface of Venus is hot enough to melt lead. So lead could not remain in a solid state the way it does on Earth. It is so warm on the surface of Venus. It would be like if you had an oven and it was on broil, like the highest it could be. The surface is even hotter than that. And another thing, so we can't really see the surface of Venus from telescopes. The clouds are these carbon dioxide clouds are way too thick to see the surface. Even the stuff that landed on Venus couldn't see very far. So what we've done is there was a spacecraft called Magellan that orbited Venus for a long time and took the best pictures. Well, they're not pictures; they're radar images. So they bounced radar, which passes right through the clouds, and they could tell what Venus's surface is like. It is very flat, but there's a lot of we think that Venus had resurfaced itself within the last million or a few million years. So there's a lot of activity. There's geological activity on Venus going on, which as recent as possibly 1 million years ago.